Good morning. So if you are watching this video, you are ready to do paragraph 2 of your lab. Now, I'm going to remind everyone, some people have done some extra credit assignments because they've worked their way through the assignments with more ease than some other people have. But everyone is required to do paragraph 2. There is a part of this that is wrong. I'm going to tell you that right now. If you go to your paper and you go down to your conclusion section, which is right here, you're not doing paragraph 1 right now. You're doing paragraph 2. This part here, you can delete. It's not actually useful for what we're doing in this lab. I would rather, of course, have done this in class with you, but since people are at such different spots, I think it's easier to go through what to do in a video. So this is your most important paragraph, and it's all related to your data. So before we do anything, you should go up to your data table and look at your data that you have here. Okay, now your data should look different than mine. I used made up numbers for mine, all right? So you might want to, I would look first in the final column that says average. This is your most trustworthy data here, okay? Because basically it's taken all of your run-throughs of the experiments, your trials, and it's averaged them together. And that kind of helps to eliminate some errors a little bit, not perfectly, but it is your most trustworthy data to look at your average. All right. So my average for no soap was 47 drops and some change, right? It's 47.3 technically. My average for 1 drop was 36, and my average for 5 drops was 19.3. So the first thing I'm going to think about is like, okay, so what's the trend? Okay, like, so as my amount of soap, right, increased, right, from no soap to 1 drop to 5 drops. So the soap is increasing this way. As my soap increased, what happened to the number of drops? All right, so for me, the number of drops consistently decreased. Okay. And so that's going to be my results. There is a chance that you might not see much of a difference or any difference really between the 1 drop and 5 drops. And if that's the case, all you really found out is as soon as soap is added, it doesn't matter how much, right? It decreases the number of drops. So keep in mind, see if you have a trend going downward or if there's just a difference between no soap and 1 and 5 drops. All right. So when you're looking at this, once you know what your trend in your data is, you're going to want to go up to your hypothesis and see, well, is that what I thought was going to happen, or did something else happen? And in science, like at least 50% of the time, our hypothesis in the end is not supported by the data in our experiment. Now, before this year, you might have been taught to say your hypothesis was right or wrong. I don't like you to use those words because guess what? You've only done this experiment, basically once with some trials in it, but you've only done this experiment once. Do you really think that your data is so trustworthy that you can say for an absolute fact that your hypothesis is right or wrong? Most of the time, the answer would be no. If you need to think of it another way, I like to think about when they're testing a new drug or say the vaccine, right, for COVID. If they had tested the vaccine for COVID on just 3 people and then came to a conclusion that the vaccine either worked or did not work, would that make sense? Would you trust that vaccine if it had only been taken by 3 people? Just like you only did 3 trials, we're talking about only 3 people taking the vaccine. And if that's the case, then the answer should be no, you should not trust it. Okay, that much. So all you're going to do is go up to your hypothesis. Okay, I said if I increase the amount of soap, then the number of drops that fit on a penny will decrease. Okay, so it looks like my data supports that conclusion. Okay, so it says right here, state whether your data supported your hypothesis or not. So supported means agrees with, all right? You can say agree with if you would rather, just don't say right and wrong, because that's not true. You don't have enough facts to say your hypothesis was right or wrong. Okay? So what I would do is I would re-remind people what my hypothesis is. So my hypothesis was that as I increase the amount of soap, the number of drops that fit on a penny will decrease. I found that my data supported my hypothesis because the number of drops consistently went, sorry, I was going to say went down, but that's technically decrease is a better word. Consistently decreased as the soap increased. Okay. You want to be clear. Yes, we're in some ways repeating ourselves, but in some ways, you can also argue, especially in this paragraph, you're trying to support your argument here. So science and English actually go together more than we think that they do. All right, because in English, you're often supporting a claim, all right, or you're supporting, help me, an argument. So when you're trying to support something, you want to have repetitious info that supports your initial statement. So your initial statement here is your hypothesis. So that your data supported it. So you're going to give repetitive information that proves over and over again that this statement was correct. Well, sorry, I cheated and used the word correct. This data was agreed with. Okay, so the next step is to give further facts. Okay, so just like if you were in English where you would find sentences or phrases or whatever from the text to support your statement, here you're going to use your data from your data table to support your statement. So let's see, I found that my data supported my hypothesis because the number of drops consistently decreased as the soap increased. My average, I'd always start with your average results first before you talk about your trial. So I'm going to talk about my averages first. My average number of drops was, oh, now I got to go up and look. I'll look at this one first. No soap, 47.3 was 47.3 drop. Oops, sorry, it jumped on me. Was 47.3 drops for no soap. Then the number of drops decreased for the container with 1 drop of soap to, you want to say specific numbers, all right, to 36, to 36 drops. This was a decrease of 11 drops. So it decreased by 11 for those two. Then my average number of drops continued to decrease with my container with 5 drops of soap to 19.3 drops. This was a decrease of, oh, I gotta do my math, guys. I didn't do my math ahead of time. 0.7. I got this right. I'm doing it in my head. You guys do your actual math. All right, so I want you to follow the exact pattern that I used here, as long as your results agree with mine. All right, you can change words here or there. This is kind of like your exemplar. So this is what I'm doing kind of with you to show you how to talk about your data. Notice I included the exact numbers, right, from my data table. All right, so here's one here. Maybe I'll bold it. You don't have to bold yours, but I'm just trying to point out to you. Here's my other one, bolded. And here's my last one, bolded. Also notice I made sure to say specifically what it was I was talking about. Right? I said I made sure to include no soap. I made sure to include 1 drop of soap. These are the expectations. That's why I'm bolding these things. You make sure that you are specific, because sometimes people just say it decreased or they're not specific enough. You're supposed to really talk very specifically about your data here to prove your point better. Okay. So this is one of those times where repeating yourself is actually a good thing. The more information that repeats what you're trying to say, the more you're proving it. All right. So the last thing is, I think I also want to include that I want to look at all my trials. Did all my trials agree? So trial 1 decreased as the amount of soap increased. Trial 2 increased as the amount of soap, decreased as the amount of soap increased. And trial 3 also followed the pattern. So each of my trials also followed the pattern. Each of my trials also consistently followed the pattern of, or maybe we should say trend, that's fancier. The trend there as the amount of soap increased, the number of drops decreased. Now, for those of you advanced guys who might be ahead of everybody else, you might want to actually go through and give more numbers, give more examples. For example, in trial 1, okay? For example, in trial 2. All right, you can do that. You're not going to talk about the sum, okay? The sum was just like an intermediary step to get the average. So you might want to continue on with your stuff that is explaining like how much data supports you. Okay. For those of you that are just trying to get this done because you're behind, all right, this is where you would end with talking about the specific data, but you're not done with your paragraph yet, because you have to explain why you think it happened. So you have to go back to remembering what we've learned about surface tension and what we've learned about what soap does to surface tension. Okay. So Each of my trials also consistently followed the trend where as the amount of soap increased, the number of drops decreased. This trend continuously occurred because um, the no soap had the most surface tension, where when soap was added, it disrupted the bonds that form between the water molecules, thereby making it more difficult for them to hold together on the penny. Now, another advanced feature for those of you that can do it, if you can add some visual evidence to support this as well, what I just said, it's a good thing to add. And we did see this. You know, this was also very visible as the dome of water on the penny was highest in the no soap group. Okay. The other two groups had a much flatter appearance, and even the drops coming out of the syringe um, were not as big or round as the no soap. All right, we're done.